I couldn't see that. Thanks. Okay, let's begin. So our list of topics includes, let me go right to the most enigmatic topic. the most confusing topic in the world, a two-way sprite. What is it and how do you do it? So we'll talk about that for at least a half an hour because it seems to be mystifying about half of you. But first, I'd like to talk about these two things. First, the parse XML. And this will be quick, but I'd like to talk about this class a little bit, which is a wrapper class around XPath. So I picked as the parser to use, I picked XPath really for a couple of reasons. So let me just talk about XPath for a moment. I haven't talked about it. So you know how XML works. Would you close the door to save the guy putting cotton in his ear? So there are two kinds of parser. Well, there's more than two always, but there are two main types of parser for XML, and they are SACS and DOM. And the difference between these two is that SACS is probably harder to use, maybe, but it's much faster and much more efficient, both with memory and speed. Now, why is that? Because SACS is pretty much line-oriented. That doesn't mean it only reads one line, but it basically reads a line and tries to figure out what you want from that line. And if that's not good enough, then it will read more lines. But in any case, it never reads the whole XML file into memory. It never does that. So as a result, it's hard to program. But I didn't think you'd care because I wrote the code. And I can go through the code if you like. And I would like to talk just a little bit about it for a couple of minutes. But the other form of parsing is DOM. DOM is actually much easier to program. And students frequently like DOM because it reads the whole document object model into memory at once. And then you can just run through the tree and look for stuff. Now, why do I prefer SACS? Well, some of the research that I've done is with building abstract semantic graphs for programs, large programs like Mozilla and things. And sometimes, and the XML representation of an abstract semantic graph for a program like Mozilla could be 50 gigabytes. So DOM would be out of the question for that. Sorry. You have to push real hard. Give it to the old, No problem. I'm just trying to keep it. Sorry, it's the guy. Yeah, well, he probably feels this is his building. I don't know. Anyway, DOM, you read the whole thing in. Now, what's the deal with SACS? Well, if you're reading one line at a time, one of the problems there, if you read a tag called, say, width, and I'm just using this for example, and then in here you have 640, and then you have the end tag. Okay? What does this mean? Well, when I get to 640, I don't know what that is in terms of SACS. Okay, so we're using SACS, not DOM. So in terms of SACS, by the time you get to 640, it doesn't know what that is. So what I do in here is I have a variable that keeps track of the last tag. Don't I? Yes, last tag. So I keep track of that last tag, and then when I create my map entry, when I see this data, then I'll make a map entry. So I'll say map of this tag. Actually, it's actually map of last tag is equal to whatever this character data is. Okay? And so then I store all this stuff in the map. And then the map is sitting here, and then game data, and this is not a singleton. This is not a singleton. Why? Well, because in some iterations of this course, we've actually saved our game. It's really cool to do, because I'll show you an example sometime where I save the game right in the middle of an explosion. And I save the game, get out, get back in, and resume the explosion, just for that adrenaline rush. But it's tedious. It's a bit tedious, so I usually don't require it, but I can show you how to do it. And when you do a saved game, you typically want to save the game in a different XML file that you're keeping all of your game constants. So I don't want this to be a singleton. So what I did was I created a singleton called game data, and it is a singleton. And it stores this map. So it stores the game map, the map with all the constants, so that it's there for the lifetime of the program, and this can come and go. So that's the idea. So that's SACS programming, and I kind of do it for you. Now, that said, SACS keeps track of a buffer, and I tend to be somewhat abstemious. That means cheap. And so I set the buffer size at 128. Now that's great, as long as you don't have a line that's bigger than 128. Typically no one will. However, some people don't like doing it this way, and they find it a little easier to read if they write stuff like dimensions, And then in here they can put width and length, and then a couple long tags, This is a long tag just to exercise parse XML. And if this gets bigger than 128, and your program's going to hang, expat will hang. Expat is the C parser. I use expat as the C parser to do this. Everybody said, by the way, before I chose expat, I evaluated various parsers. This was rated by everybody as the fastest and the best. That said, let me just point out one problem I discovered with it. The first line of code in the expat parser is a call to srand, which sets the random number. Now that can become a problem if you call parse XML more than once. Probably you won't, but if you do, you could end up with the same values coming. I'll explain that to you at some point if you want to know why. But at any rate, this is somewhat frugal. You might want to change that to 256 or 512. You won't see a difference in performance, but you will then be safe. You will be safe in the sense that none of your lines are going to be more than 512 bytes. So I just wanted to point that out to you. Also, I call this a wrapper around expat. Why? Well, expat is written in C. And as a result, there are C functions. Now, C functions actually get, names in C++ get mangled. So when I compile those functions with a C++ parser, those names get mangled, and the linker and loader will have trouble finding them. So I wrap those callbacks. Now, what callbacks are there? Well, really, when you do SACS parsing, there are only three interesting functions. The one to get the where is this? The one to get the start tag, the one to get the end tag, and the one to get the character data. I mean, really, when you get to an XML document, there are only four things you can think about: the start tag, the end tag, the character data, and any attributes you stick in there. So by attributes, I mean, and then you can actually go, is it slash? You can have it, this is called an empty tag. It's called an empty tag because there's no character data. Okay, so this is the beginning of that tag, that's the end of that tag, and these attributes, and of course you give these values: width equals 640, length equals, whatever. Okay, so these are wrappers, and wrappers around C functions have to be static, because static functions, there's only one, so you don't have to mangle them. So why does C++ net mangle names? Because you can have a getInt in 5 different classes. So to distinguish those 5 different classes, the C++, I guess, is it the compiler or the linker? Either the compiler or the linker. I'm not sure where that happens in the compilation process. It will mangle that name. And usually, have you ever seen them? It usually looks like garbage. But essentially, you'll see junk, 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 class name, colon, colon, function, junk, junk, junk. That's because it's mangled. And by the way, if you're using Python and you put the underline, underline in front of a class attribute in Python, that name gets mangled the same way. So it's really not, there's no such thing as privacy in Python. Anyway, that's parse XML. If you want to ask any questions about it, I'd be happy to answer them. But just to give you a preview of what's below, if we go into, split parse. If we go down here, you'll actually see those wrapped functions. And I hate doing this, but this is a function that gets called from the constructor. So that at the end of the constructor, the map is in a valid state. So, and that's what you want to guarantee. By the time, when you call the constructor of a class, by the time that constructor is done executing, you want your whatever data structures are in there to be in a consistent, valid state. And that's the case, but I didn't want to put all that code in the body of the constructor. So these are all expat functions, which I could go through, but you may not be interested. And I don't want to use up too much time talking about expat. But you'll see that all SACS parsers have some kind of a function, a callback function to handle the start tag, which I'm doing here. Notice I'm keeping track of course, the last tag and then the next to last tag. And some people keep a stack of the tags so they can run through and see them as they combine, because when they get to this data, they don't know what this data is. And really, you might have a tag above this that says screen width, and then another one that says world width or something. So if you nest them too deep, or if you really nest them, anyway, so there's strip, the white space, because there's all kinds of white space in front and before the data. This gets the character data in here. That's a callback. XPath uses that callback. And those are wrappers. Did I miss the end? I probably don't do anything with the end tag. I don't do anything probably for the end tag. So that's the way it works. It's kind of a blitz of it, but do you want to ask any questions? For many of you, this is probably, how many for you is this the first time you've used XML? Raise your hand. Oh, so most of you have used it before. Okay. And I know a lot of people don't like XML. The reason I use XML, I mean, I could use JSON or something else, is a lot of places, a lot of apps use XML. Certainly SVG, scalar vector graphics. What that is an XML file if you take a look at it. I've been told that Word, that docx is an XML file. Is that true? I've looked at it. It's pretty ugly. But in a lot of video games, believe it or not, use XML to save their games. That said, it's amazing they do that because they are kind of bloated. They're large. So everybody uses them. I certainly like them better than CSV. CSV sucks. I mean, it's the worst. It's great the day you write them, but 2 days later, you know, these numbers, what are they? You know, it's just hard to figure out what those numbers mean. So that's XML. I mean, that's parse XML. Okay? All right. I use a similar thing, by the way, when I write OpenGL code. And I like to avoid, with OpenGL, I like to, a lot of people using OpenGL, actually it's glut that's the problem, have tons of global variables. And what they're actually doing is they're writing, they're using a C++ compiler to compile C. If you look at it, really means like global variables, global functions, you know, because you need those callbacks. Glut uses callbacks the same as XPath does. Mine does that. Look at me. There's a plug. Sorry. What was I saying?
Callbacks.
What is it?
Callbacks.
Oh, callbacks. I hate callbacks, by the way. But glut uses callback, so you have to have a display callback, a set handler for the keyboard, the keys and the mouse. You need all those callbacks. And so what I do is I wrap that in a singleton, and I put an example of that, by the way, in your repo. Let me just show you if you want to look at it. In the repo, some people aren't good at finding things in the repo. Some other people are awfully good at it. So in the repo, I put, this is an example where I show people how to use glut and OpenGL without any global variables. By the way, I thought I was just so cool, and I went up to Jerry Tessendorf and I said, and I don't like glut, by the way, I prefer SDL. And a lot of places actually use SDL for their Canvas stuff instead of glut when they use OpenGL. Not here, not the older types. But at any rate, so I said to Jerry Tessendorf, smart guy, knows a lot of C++, knows a lot of C++ that I don't know. I said, well, do you use glut and OpenGL? And he says, oh yeah, I use it a lot. And I said, well, do you have a lot of global variables when you use glut? He says, oh no, I don't like global variables. I said, really? Well, how do you get rid of them? He says, oh, I use a singleton. And I was all ready to tell him, you can get rid of those with a singleton. And here he is telling me he uses a singleton. It really just ruined the lunch I was at. Because I was even going to bring some printouts to show him how to do it. And anyway, so I thought I developed this really great solution, so I could wrap. I have a manager class here, and there's no global variables, and I wrap them all in a singleton and call them. And he already knew it. So I used to like it before that. Now not so much. Okay, so that's that. All right, any questions about XML or parse XML? That buffer size thing actually was a bug for someone who came to see me. And it took us a good 15 minutes to find it. So, all right, let's talk about the enigmatic concept of two-way what if. Okay, what could this possibly mean? It really is a complicated thing. And what I mean by that, this isn't working. Let's see, where is it? So, what I mean by a two-way sprite is a sprite that goes in two directions. Okay, left, right, up, down. I don't know. Two directions. Okay, so he gets to the right, he turns around. And I wanted you to figure out how to do that. And there's so much confusion. So first of all, you need to do that. Now why, let me just tell you what I'm getting at, why I want you to do that. So the lights go back off, just as your eyeballs were adjusting. Why do I want you to do that? Well, my idea was, believe it or not, all these projects, besides having, I hope they'll be fun, and you'll learn lots of stuff, but each one has some software engineering goals that I would like to try and I list them actually in the project directory, what my goals are with these projects. I'm not just giving you these projects to keep you busy at night, because I think you have time on your hands. Let's face it, students have no time and no money. Except, I see students driving into the parking lot of Hendrix, undergrads with Lexus. I've never been in a Lexus. And what's that thing that Josh Levine drives? Is that a Porsche or what? Jag. A Jag. Undergrads roll in with a Jaguar. Did I say that right? With one of those cars. Like, the only time I've been in a Jaguar is with Josh's car. I mean, let me not, where was I? So, with your first project, I wanted you to just get used to a vector of object. Not object star, but object. And the challenge there is to make sure you have a copy constructor and an overloaded assignment operator. If you don't, you can get in trouble, and I showed you an example of how that can happen. That was the first project. In the second project, I would like it if you would think about having a polymorphic list. Now, what do I mean by a polymorphic list? I consider this, in a certain sense, to be a polymorphic list. So what the heck does that mean? So that means that you have, let's get rid of this, we're done with it. So by polymorphic list, what the heck does he mean? Well, I'm talking about right here. Okay? Polymorphism. Let's just review. What does it mean?